Today we are going to be going through a brief explanation of the linear regression model. The linear regression model's main purpose is to fit a linear model to data points. So you have data points as seen on the graph, and you want to find the line of best fit, which is in the form of y equals mx plus b, or as seen on the screen, y of x sub I is equal to c sub 1 x sub I plus c sub 2, where c sub 1 is the slope and c sub 2 is the intercept. Now, we want to use the method of least squares to find the best fit data line. So in order to first do that, we would find the sum of the squares of the errors and minimize the SSE, which is the abbreviation for sum of the squares of the errors. And by minimizing the SSE, which is the distance from the point to the line of best fit, we can derive the linear equation. So after you've derived the linear equation, you can use the SSE for error analysis, finding S squared, which is the confidence interval, statistically speaking, of how confident we are that this line is a good model for the data and can perfectly model the mean. So you can also use the Vandermonde matrix, which is using MATLAB in order to find the line of best fit, which I'm not going to go into much detail, but you can use the formulas as seen on the screen to find the equation of the line of best fit using MATLAB and the Vandermonde matrix. Now, the linear regression model with engineering is seen on this slide, where all sampled engineering data has errors, but a lot of times the model suggests linearity, and the output might not be linear, so you want to use the method of least squares to find the best model of the data. So in engineering, in real life, an example would be using an ideal resistor versus a measured resistor. So an ideal resistor would be linear, ideally, but sometimes when you're measuring a resistor at some currents, it is not linear. So you want to use the linear regression model to approximate using data points you've measured through the linear regression model. Thank you.